Okay, so this video is for my amateur radio friend Robert from Serbia. We've been testing on the 40-meter band and 80-meter band, and we had some nice contacts, and we tried to improve each of our stations. And he recently improved his antenna, and now I'm trying to build RF amplifier. I started with tube amplifier, but I procrastinated on this project because it's a little bit more difficult. And now I want to turn towards the solid state power amplifier for RF HF bands. And this is the power supply I just built. I wanted to show you. It's very easy power supply. It's unregulated 50 volts power supply in the rack mount. So this is power on, this is primary fuse 5 amps, 230 volts, and it gets rectified into about 50 volts of DC. Here's the analog meter, and maximum output is about 20 amps of DC. But now the fuse here for testing and safety is only at 16 amps of DC current. Yeah. So when I open it up, it looks like this. It looks a little bit messy because just after some time I started all neat and tidy, but after some time I just wanted to get it done. Here's the fan. This is the big toroidal transformer. It has 115 and 115 inputs, so 230 in series. And secondary is also 35 volts winding and another 35 volts winding. So I used to make a full wave rectifier, but with the center tap. I use a center tapped full wave rectifier, so I can get I can rectify I can rectify the 35 volts into the two windings of the 35 volts into 50 volts of DC. Here you can see the bridges I use. Those are the diode bridges. I do not use this terminal. I just cut it. I could just simply use two big diodes, but I have these and they were easy to mount. Here on a heatsink. And this is the filter capacitor, a PCB with a thick, let me zoom in maybe, with 33 volts and 6,800 microfarads each, so this times 4. This is bleeder resistor, so when I switch the power supply off, they will slowly dissipate the energy, and the voltage goes down. Some reverse protection diode. And these big resistors, they are not for the 50 volt side, they are on the 230 volt input side for soft start action, because this huge toroidal transformer, if I would energize the capacitor bank, I have some carrot stuck in my throat. This thing would like hum like crazy and like jump around because of the huge magnetic fields. I have to create some sort of soft start. The way it works, at first the AC goes through the resistors, and then I have a time relay on delay. After 10 seconds, it bypasses those two resistors, and the power goes directly to the primary of the transformer. Yep. So far straightforward. Then there's the story with the fan. It was a funny story. It got a little bit over-engineered. I got this 120 millimeter Papst fan from Norbert. Norbert is also my radio friend. He lives in the same village as I do, and we often trade parts and services, so to say. So he got me this fan. It's like it's like cast zinc or something. It has a very heavy rotor, and it works on 230 AC. But for my liking, it was much too fast and much too noisy, and it creates lots of pressure. So I just tested it out on 115 volts. So I take at the primary side of this transformer, I just take 115 volts, use it as a Spartransformator, we say in German. I don't know how to translate it. It's like directly tapped on the primary side, so it's not DC isolated. But it works. The only issue with this thing was, because it has so much mass, it needs the higher voltage to get spinning. But once it's spinning, I can switch down to 115 volts, and it has a lot, still a lot of pressure, but it's not so noisy. So I just went and did some more engineering with some crazy relay circuit. So when the soft starts, like when the amplifier starts, it will start on 230 volts, and then later when the soft start action ends, it will switch down to 115 volts. And I had a problem with this little relay. It says it's 8 amps and class AC1, so it should be able to somewhat switch inductive loads, but the contacts welded to each other, so the relay broke after only 10 times of use. So I did this other PCB with the snubber network to eliminate the switching arcs in the relay. This is 100 nanofarads and 100 ohms. Also for the other side, it's the changeover relay you will later see on the schematic I made. Also there's a 50 ohm inrush current limiter. All this madness just to turn on the fan. You know, it's a little bit over, but you know, it was fun to do actually. There's no regulation or whatsoever, but the transformer itself has very good regulation. So when I do the load test with 16 ohm or with 8 ohm, it just drops from 50 volts. It only will drop down to like 45 or even more, like 47. It's not so noticeable. I think for my application it will be all right. Now I will switch on the power supply, and you will see the voltage slowly rising until about 45 volts, and then after 10 seconds you will hear the click of the soft start completed, and it will be on spot 50 volts on spot, and of course no current drawing so far, and you will see the soft start LED light vanish, and the blue light will come on, indicate operation ready. Now operation is ready, and I have a load connected. Not connected yet, but we will make some tests. So you can observe. I have 8 ohms and also 8 ohms. So I can make 16 ohms. I can make 8 ohms, or I could even go as low as 4 ohms if I put the two resistors in parallel. But I will not do so because they will melt otherwise. They get crazy hot, and they're rated for 200 watts only, these DIY load resistors. I will switch back the camera to the panel, and you can see how the voltage drop is going when I load the power supply. Okay, now this will be 16 ohms. You can see. And now it will be 8 ohms. But I cannot test it on 4 ohms, unfortunately, otherwise my load will just melt. Okay, let's switch back the camera to the loads, because I think the arcs are already quite impressive. Okay, this is the setting now with 16 ohms of load. Now check out this nice welding arc. I could technically weld with this thing. And it gets even worse for the 8 ohm. Obviously. I can't look in it. This is just, I don't know, like 7 amps of current or so. Beautiful, right? And here you see the very, very black spot. I involuntarily tested the secondary fuse, and once I touched this one, so I made the short circuit, you can see. I made a short circuit and then I blew the secondary fuse, the 16 amp. It was a huge bang. So, you know, there's some power. I think it's good for my new project. Just look at this poor banana plug. It is completely molten, the tip, with my welding experiments. This is the schematic of the power supply. Okay. This is the AC socket, AC plug, and it's grounded to the chassis with the primary fuse, 5 amps, input switch. Now this thing here is the time delay, it's the on delay relay, and once it's done, it's switched over this contact and will short out the 2 soft start resistors. You see? The current will bypass the resistors once this is closed, the contact. And while it's not closed, it actuates the coil of the other relay, which's only purpose is to manage the fan I talked about earlier. It will make it spin at 230 and then later at 115 volts. You can see how I just tapped the primary of the transformer to get the 115 volts, and this is the other path for the 230 volts. And this PCB is the snubber, so that the fan induction doesn't kill the relay contacts anymore. It was like welded together and crazy burnt. And I had another changeover contact here, which I only used for the LEDs to display the state of the power supply. So the orange was for soft start in action, and the blue was for what am I saying? And the blue one was for operation ready. Yeah, I have the terminals at the back, and there are also terminals at the front. There's a voltage, analog voltage meter, and also current meter. Secondary fuse, bleeder resistor. Yeah, that's it. It's pretty easy, but the fan part is totally over-engineered. Sorry for that. I have another schematic of this. I'll just fold it and then take some tape and tape it inside of the power supply itself, so should anytime something break, I always have the schematic at hand and can repair it, or the person after me can repair it. That's for sustainability, you know. This will go there and then I'll close it up. Project finished. Next project, solid state power amplifier for the HF bands, 80 meter, 40 meter and 160 meter, maybe with the switching MOSFET IRFP 250N. This is what this was designed for, also for the BLF 188XR solid state RF amplifier kind. It should go in the rack and then power all sorts of amplifiers in my ham radio shack here. Yeah, so far I hope you liked the video. Maybe a thumbs up. That's it from Amateur Radio Awesome. Bye bye.